Okay, we're going to take a look at Explore 2 of electric forces. We'll go ahead and start by setting up our notes. And we're going to go ahead and use the essential question: what determines the strength of the electric force? Okay, so let's go ahead and start by, of course, writing down what you know. Or think. Okay. Things that determine the strength of an electric force include, that could be a sentence starter for you. I think some factors that affect the strength of electric force include, you could use that as well. So you're just kind of pausing your video and writing a few thoughts down here. Okay, hopefully you were able to write something down. Let's go ahead and jump right into this. Roman numeral 1, we're going to talk about Coulomb and his law. Coulomb's law. Okay, Coulomb's law has to do with the calculation of electric force between two charged objects. Okay, if you take a look in green here, paragraph 1, I have the main idea. How can the strength of these two charges be determined? Coulomb discovered this relationship in the 1780s. Second highlight there, he discovered that the strength of the electric force, F of E, that means force electric, between two charged objects depends on two factors: the amount of charge on the two objects and the distance between them. The equation for Coulomb's law is, and we can go and expand this side there. I don't know why that's so small, but it's F of E is equal to K times the charge on particle 1 times the charge on particle 2 divided by the distance squared. Furthermore, if you move down to the next paragraph, you can see that charge is measured in units of coulombs, capital C, and the lowercase r represents the distance between the two charges measured in meters. Finally, K is the constant. That's equal to 8.99 times 10 to the ninth newtons times meter squared divided by c squared. And this is what they call your constant of proportionality. Okay, so we'll go ahead and write out the law here. Hopefully you see something, some similarity to another law, the force of gravity. Okay, so here we go. Force electric is equal to K times charge 1 times charge 2, and all that is going to be divided by the distance squared between them. Okay, this is the electric force. K is a constant. Which equals 8.99 times 10 to the ninth newtons times meter squared divided by coulomb squared. Okay, by coulomb squared. Okay, the Q1 and the Q2 charges on object 1 and 2. Okay, these will be in coulombs. In coulombs. And then r squared is the distance between the objects. You'll have some practice problems that involve this formula, and as is often the case, you will not always be asked to calculate, say, f of e. You might be asked to calculate the distance or the charge on object 1 or the charge on object 2, in which case you need to be prepared to rearrange the formula to solve for any of those variables. Okay. Note how similar it looks to the F force of gravity formula, which was F of g was equal to the gravitational constant times the mass of object 1 times the mass of object 2, all that divided by the distance squared, right? Very similar type of setup. That should make it pretty easy for memorization purposes. Notice here that when they're calculating r, they use the centers, measure from center, the centers. Why? Because you don't know where exactly the electrons charge edge is. Okay, that's why we just measure from the centers. Okay, so anyway, there's a lot of things that they kind of mention here that you already know. The force electric is directly proportional. Directly proportional. So as the charge of object 1 goes up, the force electric will go up. If the charge on object 2 goes up, the force electric will go up, and vice versa. If the charges get smaller, the force electric gets smaller. They travel together. That's different than the relationship of force electric to r squared, which we say is inversely proportional. So if your distance gets bigger, and it's squared, so it's going to get bigger fast, the force, or it's as it gets bigger, the force electric is going to get smaller, and the force electric is going to get smaller quickly because it's squared. Okay, if the distance between the objects gets smaller, then the electric force between them gets bigger. They travel oppositely. Okay, and we seem to mess up there. This is called an inverse square law, okay, because the force is inversely proportional to the square of the distance. All right. All right. Well, let's continue to move forward here. You got some images. You got some stuff on Coulomb, a video segment on Coulomb's law, and then they give you a sample problem here. Okay, and in this sample problem, you can very quickly see that they're looking for you to find the charge on Q2. So that means you're going to have to rearrange the formula so that you're solving for Q2. Okay. They walk you through this. Okay. And then they go ahead and plug in the numbers. So I want you to look at this example carefully and see if you can do this. This is not new for you. We've worked on rearranging formulas in the past. Okay. Um, and then you're going to have some problems that you have to solve here. Okay. Alrighty, I think that that's it for us. We'll see these in your formative as homework problems. Yep, that was pretty short set of notes today. Okay, so let's go ahead and just, oh, did we already? Yeah, we did that. Let's go ahead and just draw this here, and let's go and write down a summary paragraph. Okay, and that'll do it. We'll talk to you a little bit later.